Okay, in lesson 18 we are going to talk about graphing logs and periods of function. Alright, this first one says to sketch y equals log base 4 of x. Now you know you can't put that in your calculator. So if you had to do it by hand, you would rewrite it as 4 to the y equals x. You would do a t-chart and you would get your basic log shape. Now all the logs have similar shapes. It's just that their bases will change the values. Now when you look at 18.2, it says to sketch this. Again, I rewrite it in exponential form. I put it into a t-chart, and now what happens is, if it was going this way, this negative says it's reflected. So what was up here now flips, and that's why you get this one. Now in an example 3, we're saying our base is bigger than 1, and we want to graph y equals log base b of x, y equals negative log base b of x, and y equals log base b of negative x. I rewrote these so that they would all be in exponential form. And now what I did is I got a t-chart for this first one, and I get these values, so it's going to go like this, which is a regular log function. This is a negative, so it reflects across here. So what was here is now flipped. And now what we have here is that this is a negative x. So what we have here is that what was positive x's are now going to be flipped over this way. So if you took this one and flipped it, this is the one you would get. And that's how you do 18.3. Now part D of 18.3 says that we have a negative log and a negative x. So not only do we reflect across this axis, the x-axis, but we also reflect across the y-axis. Now you could rearrange it, plug in values, and this is the form you would get. Now let's graph the natural log of x. It's an absolute value. So if I rewrote it, no matter what I have for e, or what I have for x, I'm going to always get a positive value, or I should get a positive value. So I plug in my values, I get these two graphs. Now let's sketch y equals negative log base 1/4 x. Because it is a base 1/4, it might be just a tad different. And I rewrote it like this. And then what I ended up doing is plugging in certain values. If I plug in 0, I get 1. If I plug in 1, if I plug in 1, I'm going to get 4. If I plug in negative 1, I'm going to get 1/4. And so that's why your graph looks like. Right, let's look at 18.6. Sketch this one. Different base, negative x. I rewrote it. And then I could rewrite it like this. So if I stick in 0 for y, I'm going to get a negative 1. If I stick in 1, I'm going to get a negative 2. If I stick in negative 1, I'm going to get a negative 1/2, and it looks like this. The next one says to graph this trig function. So what we have here is a cosine. So I have written down, this is what I'm going to graph. I go down 10, I stretch 4. Notice I factored out the 3. That tells me that my period is going to be affected, and that I went to the right 45 degrees. So instead of doing my period in 360 degrees, it is where I repeated 3 times in 360. So my new period is 360 divided by 320. So I've got a regular cosine wave, and that's how I draw it. Then I draw my vertical axis. This is my center. So right through the center is going to be y equals negative 10. It says I go up 4. So if I go up 4, I should end up with this value being negative 6. So this value ends up being negative 6. And if I go down 4, I get a negative 14. That covers this. Now I know that I went to the right 45. So from here, that's the top of my cosine, I start 45. And I have a complete cycle 120 degrees further, so that ends up being 165. If I took 45 minus 120 degrees, I would get a negative 75. And that makes it real easy to sketch these.